We are asked to find the inverses of the following matrices. Let's recall that the inverse of a matrix can be found in multiple ways. So for a 2 by 2 matrix, which would be these two, with 2 rows and 2 columns, we can use the following formula. The formula is as follows. If we have some matrix defined by A, B, C, and D elements within the matrix, inverse of a 2 by 2 matrix is going to be this formula. We're going to take 1 and divide that by A times D and subtract B times C. Then we're going to place D in the top left position. We're going to place A in the bottom right position. Then we'll make B negative and we'll make C negative. So let's apply this formula to matrix A. We are given, well, first find AD minus BC. In our example, A times D is 15 and B times C will be 8. So AD minus BC is 7. Second, set up the following matrix. Remember that for a formula to find the inverse of a 2 by 2 matrix, we apply the formula by setting these elements equal to A, B, C, and D. What does that mean? Element A will be 3. So instead of being in the top left corner, it will be in the bottom right corner. Element D will be in the top left corner, and elements B and C will stay in the same position but will be negative. So we'll have negative 4 instead of 4 and negative 2 instead of 2. Next, set up the formula for the inverse. That would be 1 over AD minus BC times the matrix D negative B negative C A. We have 1 in the formula, so we're just going to apply it here as well. And we found AD minus BC to be 7. So we'll have 1/7 times 5, negative 4, negative 2, 3. Lastly, remember that if we multiply a matrix by a scalar, that's the same as multiplying every single element in the matrix by that scalar. So A inverse will be equal to 5/7, negative 4/7, negative 2/7, 3. First, we need to find AD minus BC. That would be 7 times 3 minus negative 2 times 1. This is going to be equal to 23. Then we're going to set up the following matrix. Remember, the way that we set this up is by switching these elements and changing the signs of these. Since this one was negative, we're going to change its sign to be positive. Then we take 1 over this number and multiply that through every element of the matrix. Now, this formula is great for 2 by 2 matrices, but how would we go about finding the inverses of a 3 by 3 matrix? Let's go over an example. The first thing we want to do is set the matrix equal to the identity matrix. Now, what is the identity matrix? I will show you what that looks like. For the matrix 1, 2, 3, 0, 1, 4, 5, 6, 0, the identity matrix has 1s along the diagonals and 0s elsewhere. The identity matrix is also going to be the same size as the matrix that you are working with. Then we need to row reduce the original matrix. This is the longest step. So I'm going to show you what that looks like. We first want to turn this into a 0. So we can multiply the top row by negative 5. 1 times negative 5 is negative 5. Positive 2 times negative 5 is negative 10. 3 times negative 5 is negative 15. And 1 times negative 5 is negative 5. We'll proceed with the regular steps for row reducing. So we're going to add row 1, so all of row 1, all of this, to row 3, and the result that we get will replace what is in row 3 currently. Negative 5 plus 5 cancels out and gives us 0. Negative 10 plus 6 is negative 4. Negative 15 plus 0 is negative 15. Negative 5 plus 0 is negative 5. This element here will stay the same because we're just adding 0. And this 1 will remain unchanged because we'd be adding 0. now that we have zeros here and here, we're done reducing this column. The next pivot that we want to reduce would be this one right here. We can turn that into a 4 by multiplying every element in this row by 4. The reason for that is we'll get 4 here, we'll add it to -4 to get 0. So let's look at how we do that. 1 times 4 is 4. 4 times 4 is 16. 0 times 4 is 0. That's also why I didn't bother multiplying this one here by 4, because the result is still 0. And then 1 times 4 is 4. Then we're going to add row 2 and row 3, and the result that we get will replace row 3. 4 plus -4 is 0. 16 plus -15 is 1. 0 plus -5 is -5. 4 plus 0 is 4, and 0 plus 1 is 1. Now that we've gotten the bottom left corner of this matrix to be triangular, meaning the bottom left corner has zeros, we need to repeat this process of row reduction with the top left, with the top right corner. Essentially, we need this to be in row reduced echelon form. To make these calculations easier, I'm going to divide these all by 4 again. Remember, I had multiplied them by 4 earlier, so I'm going to divide them all by 4 so that I'm working with smaller numbers. The next element that I want to attack is this one. I want this to become 0. So what I'll do is multiply this entire row by -4. 1 times -4 is -4. -5 times -4 is positive 20. 4 times -4 is -16, and 1 times -4 is -4. Now I'm going to add these rows together. So essentially I'm adding this row plus this row, and I'm going to replace this row with that result. Let's see what that looks like in action. -4 plus 4 is 0. 20 plus 0 is 20. -16 plus 1 is -15. And -4 plus 0 will be -4. Similar to what I did earlier, I'm going to divide all of these by 4 to make my calculations easier. I'm also going to divide all of these by -5 to make my work easier. Divide this by 4, you get -1. You divide this by 4, you get 5. Dividing this by 4, you get -4. And here you'll get -1. I'm going to divide this top row by -5. Next, I need to get rid of this right here. So in order to do that, I need to multiply this entire row by 3. I'm going to add this row and replace this row with the result. So 1 plus 0 is 1, so 1 goes here. 2 plus 0 is 2, so a 2 goes here. 3 plus -3 is 0, so a 0 must go here. 1 plus 15 is 16, so a 16 must go here. 0 plus -12 is -12, so a -12 must go here. And lastly, 0 plus -3 is -3, so a -3 must go here. Finally, we want to make this a 0. So I'm going to multiply this entire row by -2 so that this becomes -2 and cancels with this. Then I'm going to add this row and replace this row with that result. 0 plus 1 is 1, so in this position should be a 1. -2 plus 2 is 0, so in this position there should be a 0. 0 plus 0 is 0, so in this position there should be a 0. -40 plus 16 is -24, so in this position there should be a -24. 30 plus -12 is 18, and 8 plus -3 is 5. So I have the matrix in row reduced echelon form, or do I? I don't. These need to be 1s in order to be in row reduced echelon form. So as a final step, we're going to divide this row by -2 so that this becomes a 1. So let's do that. -2 divided by -2 is 1. -40 divided by -2 is 20. 30 divided by -2 is negative 15, and 8 divided by negative 2 is negative 4. Similarly, we're going to divide all of these, basically this entire row, by negative 3. Lastly, a density matrix should have turned into the inverse of the original matrix. C inverse equals negative 24, 18, 5, 20, negative 15, negative 4, negative 5, 4, and 1. If you'd like to see me work out matrices D, E, and F for their inverses, or if you'd like to see more content on how to verify whether the inverse is correct through matrix multiplication, feel free to comment below for those suggestions. I will be making a second part to this video to find the inverses of E and F.